Hi everyone, I'm Reuven, and I'm going to talk to you today about what happens when you import a module. So a few words about who I am. So I teach Python. I've had my own business for more than 25 years. I've been using Python for about 30 years now. And basically every day I'm in a different city, different country, different company, teaching them Python. I have a whole bunch of courses that I teach to companies. I have a whole bunch of courses that are video recordings that I teach to individuals online. I have some books, Python Workout, Pandas Workout. I have a free weekly newsletter called Better Developers with about 25,000 subscribers. And I just love helping people improve their Python skills. And every single day when I'm teaching, I learn something new because people ask me really good questions. So I'm expecting to learn something new after this talk. So let's start off with a really important phrase, dry, don't repeat yourself. Many of you maybe have read the book, The Pragmatic Programmer. And the Pragmatic Programmer introduced me to this phrase, don't repeat yourself. There, I just did it. I repeated myself. And the whole idea of a lot of things in programming is to avoid repeating ourselves. So how do we dry up our code, as they say? Well, if I have a few lines in a row that are the same, or mostly the same, I can dry up that code by using a loop. And we don't think about it, but that's what we're doing. What if I have the same code in several different places in a program? Well, then I can use a function, right? And I don't know how many times this has happened to you. I have the same code in several places in my program, and I say, okay, I could put this in a function, but what are the chances that I'm going to have to change it at any point in the future? I will tell you, the chances are 100%. And then you're going to have to go through each of those places and change them. So just put it in a function, dry up your code, and then you'll only have to fix it in one place. But what if I have repeated code in multiple programs, in different programs? Then I'm going to use a library. And that means that I put the code in one place, I import it into my code from wherever I'm going to need it. And if and when I ever need to improve that code, I can do it in that one centralized location, that library, and it'll trickle through to everything else. By the way, just a few months ago, I learned that the opposite of dry, don't repeat yourself, is wet code. Write everything twice. And I really enjoyed that. Okay, so in Python, we have these things called modules. And modules are our libraries. They are usually, not always, but usually files containing Python code, but they also do something else. They also provide us with namespaces. And why do I need namespaces? Because let's say I'm working with someone else. I know, heaven forbid, right? But let's say I'm working with someone else on some code, and I decide to use the variable x, and they also decide to use the variable x. I don't want to encounter, and more importantly, they don't want to encounter a namespace collision. And so by having separate namespaces, my x and their x will never have to clash, and we can both live harmoniously together. So modules provide us with these two different pieces of functionality all together, mixed up together. And modules are generally seen as one of the easier things we can use in Python. There's something we learned from very early on in our Python careers. We use them all the time, and we don't think too much about it. But it turns out that under the surface of this seemingly very simple thing is a very, very complex mechanism. And by the way, we are not going to get to all of it today. We're just going to scratch the surface, but a deep scratch, let's call it that. So, without further ado, let's import a module. Import random. There we go. Randomness at play right there. So I say import random. What is actually happening behind the scenes when I do this? Well, the first thing to realize is that import is actually doing two different things. It, first of all, creates a new module object. Remember that everything, absolutely everything in Python is an object. And so it makes sense that modules are objects as well. It then assigns that module object to a variable. And if this sounds familiar, it should. This is what happens when we define a function. What does def do? Def creates a function object and assigns it to a variable. What does class do? Class creates a type object, a class object, and assigns it to a variable. So really, import is very similar to def and very similar to class in that sense. So some things to notice when we use import. First of all, import is a statement. It's not a function. So don't use parentheses. I see people doing this all the time, and no, don't do it. But the other thing, and the weirder thing, and the thing that's harder for people to get used to, is that when we use import, we give the name of the variable we want to create. We do not give a string. We do not give a file name. So you cannot directly tell Python what file you want to load. And this is very different from many other programming languages, where you say, I want to load such and such a file. No, that's not the way it works in Python. In Python, you say, this is the variable I want to create. Hey, Python, based on that hint, go out and figure out what I mean. Okay, so let's say I've done this. Let's say I've gone off and I've imported random. As I said, everything in Python is an object, and we can always ask every single object what its type is by using the type function on it, type built in, I should say, because it's really a class, but fine, type. And we say, what is the type of random? And it's module. And module objects are actually pretty darn simple. Module objects are very simple. They're more or less namespaces using attributes. And attributes are one of the key functions in Python, one of the key features of Python. Every time you see a.b, A is a variable, but B is an attribute. It comes after a dot. And we're going to return to this quite a bit talking about attributes here. Modules don't have any methods built into them. They're just basically storehouses for information. So we stick our stuff into the module object and then we can use it. Okay. What if I want to change the variable name? Well, I can use as, right? So I can just say import random as R. The only thing that this changes is the variable that's created. Python still looks in the same place. In a moment, we're going to see where it looks and what it's doing, but still looks in the same place for our module, loads up the same thing, does the same thing. It just assigns it to a different variable. Okay, well, how about this? What if I have two modules, A and B, and A imports B, and B imports A? Now, I've heard some languages that are somewhere between B and D that have problems with this kind of thing. Because basically, in those languages, and I wouldn't want to name names, but those languages, basically, you need to be very careful, otherwise you can get yourself into an infinite loop. This one loads that, and that one loads that. So then you have to do all sorts of crazy things like define and if-def and if-and-def. Clearly, such languages are never going anywhere, but fine. In any event, in Python, I don't need to worry about that. Because basically, Python keeps track of what I have loaded. We don't want an infinite loop here, and it doesn't happen because Python only imports a module once per session. It will always define the variable. It will always assign to A, it will always assign to B if we've done the import to there. But it will only load the module once. Well, that raises a question. How does Python know? How does Python keep track of this sort of thing to know if a module has been imported already? And the answer is, of course, a dictionary. And the dictionary is called sys.modules. Now, sys, by the way, is a special module where it's already loaded into Python when we start up the language. It's already available, it's already in use, only the name does not exist. So when you say import sys, it's actually a really, really, really fast thing to do because all you're doing is defining a variable. Sys already exists in there. And so sys is this dictionary that contains all the modules. This is our module cache. The keys are the strings, which are the module's names. And by the way, there are the names of the modules as they originally appeared, not our aliases. And the values are module object. And so if you ever need to sort of convince someone, Python dictionaries, okay, the keys are kind of limited, they have to be hashable, but the values can be absolutely anything. This is a great place to show them, because if module objects can be stored in a dictionary, anything can. Okay, and so when we import, Python checks if the module is already there. If not, then it imports the module and adds it to the sys.modules. And then it can assign a global variable to that value. This happens every single time we use import. It checks in sys.modules, and if it's not there, it imports it. If it is there, it doesn't do it. Well, how many modules are loaded up by default? So I did a little bit of experimenting here. So I loaded up the interactive Python shell, and I said import sys, because I need to import sys, and I said, tell me, how many modules are there? 79. So that's like the smallest number of modules you will ever see loaded into a Python program. That's like literally doing nothing other than importing sys and sort of what you need for the interactive shell. Well, what if I'm a fancy user and I decide to use the IPython shell? Well, then it's going to be a little bigger and slipperier. IPython is 646, and Jupyter, giving away the store, Jupyter has 1,020 modules. No wonder Jupyter takes a while to start up, right? It has to load all these modules. So what I want to do now is show you some pseudocode. So let's look at some pseudocode to figure out what's happening when we're importing our module, right? Don't really run this code. It won't really work. It's like 90% Python and 10% imagination. All right? So instead, by the way, if you ever want to do things that are sort of like the import system, you should use importlib. Importlib is a module, of course it is. It comes with a standard library, and it implements the import system. So if there's ever a part you want to re-implement yourself, you just go ahead and do it. You either use parts of that or look at parts of that to do it. And it's designed to be read and studied and used, and I'm going to use the importlib module a bit here. So here's what my import pseudocode looks like. I'm going to say def my import. This is my function here, and mod, that's going to be the name. It's going to be a string. And then I say, oh, I guess I should change the mod name. Ha, there's already a bug. It's a pity there's no debugger for pseudocode, right? So if mod name is not in sysmodules, then sysmodules mod equals get module mod. Meaning, if we have not yet loaded this module, then let's get that module and we'll stick into sys.modules. And after that, we know that the module object exists, and thus we can assign it. Wait. We can assign, what the heck is this thing? Well, it turns out that a built-in function in Python is globals. And if you call globals, you get back a dictionary containing all of the global variables. The keys are the global names, and the values are the global values. Yet another good way to demonstrate to people that anything can be a value in a Python dictionary. And it turns out that not only does it return the dictionary of global variables, you can assign to it. Now, don't do this at work, unless you really hate your colleagues. But don't do this at work. However, we can see that it works pretty well here, and we can assign to it. Now, what is this get module that I'm pretending exists? That's the imagination I mentioned before, right? So we're going to get back to that. Well, what about import as? Well, I can say import as sort of like this. I can say def my import of mod and alias equals none. So if I just do an import, then I don't have an alias. If I do an import as, then I have an alias. So if mod not in sysmodules, exactly the same thing. I'm once again checking, is the module loaded? And if not, then I'm going to load it up with my imaginary get module, and then I'm going to check, is the alias none? If it is, then I'll just say the alias is mod. I'm just going to use the module name. But if there is an alias, I'll use that. And then notice I'm going to assign to global's alias whatever I have. Well, how about this? Going back to something I mentioned before. What if my top level program says import A, and then module A says import B, and module B says import A? Well, what's going to happen here? Well, the program says import A, and A is not in sysmodule, so A is loaded. And then the global variable A is assigned to sysmodules A. So far, so good. Module A imports B. B is not in sys.module, so B is loaded. And the global variable B is assigned to sys.modules of B. And then module B imports A, right? So we're sort of going back, and it says, wait. A is in sys.modules, so it does not need to be loaded. So nothing happens there, but the global variable A is assigned to sys.modules A. Well, there's a little bit of a problem here. Global variables. First of all, ew. Second of all, in a lot of languages, global variables are available throughout the entire language. They are global. I know, crazy. In Python, global variables are not really global. They're not universally available. They're available in a module. They're available in a file. They're available in one namespace. And so when we say global variable, it really is just one single file there. And so module A can have a global X that's totally different from module B's global X. So when we say that we are assigning to a global, you can't just say, oh, I'm assigning to a global. It is a global within a particular module. And you can always check what namespace we're in with dunder name. Dunder name will tell us what module we're in now. And the first namespace, the one that's used for the initial program that we load up, is called dunder main. Remember, dunder name is a variable, dunder main is a string. I know, who would ever mix this up? Not you, but maybe you know people. Anyway, so let's rephrase things just a tiny bit. When our program says import A is not in sys.module, so A is loaded again. And here I'm going to say A in main, in our main namespace, is assigned to sys.modules A. Okay, so far so good. Then module A imports B. And here it's actually going to be A.B is assigned because B is a global in the module A. So it's not available universally, it's just within there. And then of course when B imports A again, then B.A is assigned to that. So this actually works, and it's like only when you take it apart in this way does your head start to hurt. Normally, I'll be passing out Akamol after the talk. But basically, only when you sort of think about it in this depth does it start to sort of not make sense, because actually modules sort of make sense most of the time. Well, you might have seen the following. What if I say from random import rand_int? Okay. Does this save memory? No, it does not. I can't tell you how many people believe it saves memory. And I know this because I was once one of those people. It makes so much sense, right? I'm only interested in rand_int. Why should it load the entire module? But Python modules don't work this way. Because does it load the entire module? Yes, it absolutely positively does. The only difference when I do from import is what is assigned, not what is loaded. So if I want to do from import, I can say from random, import rand_int. What does it do? Well, it checks if random is in sys.modules. That's the first thing it does. If not, it loads the module, just as we've seen. And then, here's the difference. It defines rand_int as a global, not random. Which means, if you only do from random import rand_int, random is not defined. Only rand_int is defined. Okay, so it's loading the module object, but it's not defining the module variable. And here's like some pseudocode we can use to understand this. So I'm going to say def my from import of modern splat names. Splat names is going to be a tuple, and it takes any number of positional arguments, and these are all the names I want to import. So once again, that first part is going to be exactly the same as before. If the module has not been loaded, then we load it. And then I go through each of the names, and then I'm going to say, okay, globals of one name, and here I'm going to use some extra magic. Get out our sys.modules mod of one name. Yet another way to get your colleagues to hate you. But basically, what is this code doing? Whenever I say A.B in Python means go to A and retrieve the attribute B from it. That is turned into getAttr. GetAttr A, string B is the same as A.B. So here I'm saying go to sys.modules mod and retrieve the attribute, one name, whatever that happens to be, from there, and then assign it to that variable. By the way, you can also do aliases here too, right? You can say from random import rand_int as rand_i, and I have some pseudocode for that as well, because why not? Right? Because you don't have to debug pseudocode, as I said. Right? So here I'm going to get splat names. I'm going to go through it all. Oh, I should have said double splat kwrgs. Oh, wow, I really need to debug this thing. Whew. All right. Anyway, pretend that that's a double splat kwrgs at the top, because we're going to get a dictionary, name value, name value, name value, and then at the bottom here, I'm going to go through the dictionary and assign the name to the value. Here's something else you can do. You can say from random import star, and this imports all names from random as globals. And by the way, the module can restrict this a bit by defining dunder all. I have a little bit of advice about this. Please never do this. It's terrible. Well, what's wrong with it? Right? And I see people all the time say, well, it's so much easier. From blah, 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 import star. It's like saying, what could possibly go wrong if we get rid of last names in the world? There won't be any confusion, right? There might be. Right? Don't do that. You're not only inviting people to basically have variables trample on each other, and God knows in which order, but you're getting rid of the whole idea of namespaces. Not so good. Anyway, let's get back to a little bit of our pseudocode. This get module business. This function that I kind of made up, this imaginary function, what does it do, or what do I want it to do? Well, since it's pseudocode, I can tell you what it does. Get module takes a module name as input. It takes a string. And then needs to do find things. It needs to find the file for our module, and then needs to load that file, And then it gets that module object, it returns a module object, and then we store it in sys.modules. Here's the cool thing, get module really exists. It's called importlib.importModule. Now there is also a built-in called dunder import, and that's basically the functional equivalent of the import statement. So if you really want, you could use dunder import in your programs instead of the import statement. Once again, please don't do this. But if you really do, for whatever reason, need to import things via a function interface, import module is designed to be nicer, easier, and better. And what do? I say importlib.import module, oh, there's an underscore there that should not be there, random. And it gives me back a module object, and I can say, what's the type of R? It's module, and I can even run r.randint, and I get a random number there. Well, you think it's random. I planted it. But wait a second, how does Python find these modules? Well, here's the simple story. The simple story is that we have once upon a time, there was a list. It's called sys.path. It's a list of strings. And basically, Python looks through that list of strings one by one to find out if our module is there. So if I say import random, it's going to look in each and every element of sys.path to find random.py. And once it finds it, huzzah! Yay, we found it. What if you give the same name as something that exists later on in sys.path? Bad news. Let me give you an example. So in my corporate training classes, I often would give, or often still give, I guess, a simple game, a number guessing game. It's kind of like the lottery, but with the equally bad chances of winning and no money. So it's a real winner. And basically the idea is that the system chooses a random number, and then the person guesses the random number, and it says, too high, too low, you got it right. Great. Inevitably, someone would call their program random.py. And then their program would say import random. Well, the first place in sys.path that something looks is the current directory. So their program would import itself and immediately exit with an error saying, what is this rand_int you're talking about? I've never heard about this before. Chaos ensued. Tears, firings. Okay, I exaggerate slightly. In any event, try not to do that sort of thing, but things seem kind of weird with sys.path. Now, what if I look at sys.path? I open it up in the Python shell, and I join together sys.path. It's a list of strings, and I get this. And by the way, you can't see it because it's empty, but this is an empty string here. So the empty string, followed by a bunch of different directories, followed by site packages, and we're going to go through these now. The first part of sys.path, sys.path 0, is usually the program's directory, the directory in which the program is located, not where you're running it. It's where the program is located. Now, if sys.path 0 is the empty string, as we just had, it's basically because when you use the Python interactive shell. Either way, it's going to look in the current directory. It's not going to be a problem, no matter what. Python always looks at the current directory first. Okay, well then what? Well, after that come all the directories for the Python standard library. Right? Python standard library is those modules that come with Python that are available to us. They're not loaded into memory right away, but they are available. I can say import to any of those names. And you see that there are actually three things here. There's a zip file. We'll talk more about that later. And then there's a directory, and then there's a directory called libdinload for dynamic loading of compiled things. And so this is indeed, the standard library, and again, they're not automatically imported, but they are available. By the way, why are they not automatically imported? Because it would take so incredibly long and use a ton of memory. And so they're available. We can import them if and when we want, but they don't need to be available right away. And then finally at the end is site packages. That is the directory into which pip installs things when we download them and install them from PyPI. So if you look, I mean, obviously your system will be a little different, but like your system site packages, your Python site packages is where pip installs things. And it comes after just about everything else. Well, what if I want to modify sys.path? Well, the thing is, sys.path is defined when Python starts up. And it is a list of strings, so you can use list.append on it, or list.insert. Don't do that, right? Because at best case, you've done it for your particular program. What, you're then going to go to each and every one of your programs and insert your path name in there? I don't think that's a good idea. The better answer is to set Python path, the environment variable. And anything in Python path is inserted into sys.path at point 1. So for example, if I say, here in my Unix machine, right, export Python path equals hello and goodbye. And notice I have the path separator, same as on the rest of my machine. So now we see that, okay, empty string, and then the things that I added from Python path, and then the standard library, and then site packages. So let's do a little pseudocode now to understand what happens when we import along with this. Well, I want to import a module with a potential alias. Where things are going to get more interesting is I'm going to say for one directory in sys.path. So I'm going to go through sys.path one by one. And then I'm going to say, well, let's find that file. Can we find it? I'm going to take the name of the module, add.py to it, look in that directory. Do we see it? If the OS path exists, then yeah, let's load it up and we break. But look at this else here. This else is not with if. This else is for. And for else looks a little weird to people. Don't confuse it with the threat or else. It's for else. And else here means if we got to the natural end of the loop without encountering a break, then this will run. So if you don't have a break in your for loop, there's no point in having the else there because it'll always run. But this is a way for us to say, oh, we did not find what we were looking for, so let's raise an exception. And now I've got a different pseudocode module. Now, pseudocode function, now I've got load module, because we're finding our files just fine. Or are we? There's some problems with this story. Problem number one is some items in sys.path, as I said, are not directories, like we saw that zip file. Some are, well, modules are stored in many different places. And here's another weird thing. I told you that story about random.py, that if you create a file called random.py and then you say import random, it will import itself. If you create a file called time.py, it will not be loaded before the system's time.py. So there's something weird going on here. And let's not forget that Python creates PYC files, compiled Python files, and then does some caching of them. And let's not get started with packages, which are directories containing modules. The solution to all of this in the world of Python modules is finders and loaders. That's really what they're called. They didn't ask me first. So finders say, does this module exist? They go out to the world and look around. And then they say, well, now that I've found the module, how am I going to load it in? And their job is, what a finder does is it returns a module spec, a module specification, which has all the information Python needs in order to load it. Well, a loader, our second type of object here, it knows how to create a module object. It knows how to go to the module file and actually execute it, and then it populates that module object with attributes. Now, sometimes you'll have an object that does both of these things at once, and those are known as importers. So remember that nice story I told you about sys.path? Yeah, it's going to get more complicated now. How complicated? Now we have a metapath. You've heard about the metaverse. Python beat them to it by 10 years. So sys.metapath is a list of finders and importers. Notice, it's just finders and importers. The loaders are not involved here so much. And each implements a class method called findSpec. So what we're going to do is we're going to go to each of our finders and importers one at a time in our sys.metapath and say, can you find this module? And can you find this module? And each one of them in turn is going to get a chance. It returns none if it cannot handle this type of module or can't find it. It returns a module spec, that's the ideal, which tells Python how to load the module, or it raises module not found, it couldn't find it at all. So what's going to happen is we are going to go through this sys.metapath one by one, giving these different kinds of finders a chance to load our module. So let's try this. And again, this is sort of pseudocode, but it actually works. I guess it's non-pseudocode. Fine. So we're going to import sys, right, because I'm going to need that. And then I'm going to walk through for one finder in sys.metapath. I'm going to print its name to see what it is. Then I'm going to say, let's run it. One finder, find spec of random and none, and that just gives it a sort of a place, where it's always going to be none for us now. And then we're going to get back something. Print spec. Now remember, we might get an exception, although we won't in these cases, but we're basically going to either get our module spec object back, or we're going to get none. And if spec, then we're going to break. So let's try this now. If I run this, as I just showed you, we're going to try the distutils meta finder. None. Nope, not working with random. Then we're going to say, well, what about the built-in importer? Nope, none. What about the frozen importer? None. It's summer. It can't be frozen. And then we're finally going to use the pathfinder. And the pathfinder says, I'm going to try to find this on disk. And yeah, we found it. And the module spec object that we have down here says, yeah, I found this module and I know how to load it using this kind of loader. That's my loader. And I know where the file is. I found that too. Fantastic. But remember that example I gave you just now with time? I know we can never find time, but we're going to try. If I say here, import sys, we're going to go through it one by one by one. Same thing, just time instead of random. So, distutils meta? Nope. Built-in? Yes. Meaning time is not imported from a file. Time is imported in this special different built-in thing. What the heck? Shouldn't it be in a file? And the answer is no. There are a bunch of modules that are already loaded into Python. And that, remember I said before about sys? Time is another one of them. So you can call a file sys.py if you want. It won't affect things whatsoever because of this built-in importer. Well, how about math? Right? I'm going to go through and look for the math module. Well, what happens then? Well, distutils, no. Built-in, no. Frozen, no. Pathfinder, I hope so. And it did, but it found something different. It found it here with the extension file loader. So we see that it's a different loader than we had before. And it's in a different origin. Remember before that we saw that the standard library has several different locations. It has that zip file, has a directory, and then has a dynamic loading directory at the end. This is from that dynamic loading directory, right? It's from that CPython 310 darwin.so, which means it's compiled into C, which indeed the math module is. So Python has to be pretty smart here about how it's going to find things in different ways. But no matter what, assuming it finds our module, it has a module spec. And the attributes of this module spec object, well, they describe the object and how to load it. We have its name, we have its origin, we have the cache. I just want to take a few moments to talk about this. So when you import a module, Python says, wait a second. This is in Python, and I can read that, right, because Python's pretty good at reading Python. But it would be much faster next time around if I had it in a byte-compiled form already, if it were sort of pre-chewed for me. So that's what Python does. It takes it, it turns those byte codes into a file, a PYC file, and stores it. You might have seen that dunder py cache directory in your modules directories in the past. And that's great, and it works. I sometimes have clients who say, oh, PYC files. We can give those to our clients, and then they won't ever be able to read our source code. No, that's not true. It's very easy to decompile Python code and turn it back into code, and it'll be almost identical to your original code, right? If you want to make your Python completely unreadable to your clients, the easiest way is to switch to another language. Python is not designed to do that at all. Or you can do a SAS, right? But that's never going to go anywhere. Anyway, then we have the loader, we have its location, we have some other information. So at the end of the day, what's going to happen is we're going to go to the spec, this module spec object that we got back from the finder, and we're going to say, hey, spec, create a module based on your spec. Now, if this returns a module object, and it should, then great. But if not, then you sort of have to manually go through and assign a whole bunch of attributes. You have to say it's dunder file, it's dunder loader, dunder spec. But there's a way easier way to do this. Remember import lib? Yeah. We can go to import lib and say, I'm going to say import lib.util module from spec. And what does this do? It takes our module spec, which tells it where the file is, it tells it how to load it, it loads it up and turns it into a module object. And then I say, hey, module object, what attributes do you have defined? And these are the attributes that you've probably seen if you've ever done a dir on an empty module. Like if you create a file that has nothing in it, literally nothing, is 0 bytes long, and you import that file, these are the attributes you're going to see. They come from the module object that was created from module from spec. And many of them were copied from the spec file. or from the spec object, and dunder spec has the spec if you ever want to look at it. That's great. But our module object does not yet contain any of our module's definitions. Right? So I can have whatever classes, whatever variables, whatever functions I want defined in my module, and so far they are completely being ignored. For this, we're going to have to load the code from the module. And here, again, I have to take a few moments to explain something. When I import a module, the module is executed. There is no way around that in Python. If the module defines a variable, well, how does it define the variable? It uses assignment, a equals 10. There is no such thing as a statement in Python. Well, except for the statement, whoa, what an amazing language, right? But Python doesn't have any declarations. We can't forward define anything. Either the variable has been defined with assignment or it has not. So if we want to define this variable, assignment needs to run. If the module defines a function, def needs to run. If the module is a class, then class needs to run. Which means that when we load a module, it is run top to bottom. If you really want to mess with people's heads, you can put print statements in there, you can put while loops in there, you can do all sorts of crazy stuff. Once again, please don't do this unless you dislike your colleagues. But I think we're done with that for now. If you still have colleagues after doing even half the things I've suggested, wow, I don't know, praise to you or praise to them. In any event, modules must be executed when we load them. So how does this happen? Who's executing the module? Well, there is a function called exec in Python. And there are actually two functions that work together. One is called eval and one is called exec. Both of them take strings. Eval expects to get a string that contains a Python expression, and it returns the value of that expression. So you can't do any statements. You can't assign, you can't have if, you can't do all that stuff. But you can say like 2 plus 3 and it'll return 5. So this is useful for evaluating expressions. But exec is not meant for expressions. Exec is meant for pieces of code. You hand it a string, and that string contains some Python code, and it is executed. Moreover, it executes that code. So here, for example, I have s, first print hello, then say name equals Reuven, then print goodbye. And now I'm going to exec it. And look what I get back. Exec of s, it prints hello, it prints goodbye, and when I check what is the value of the name variable, it has been set to Reuven. In other words, the variable assignments inside of the exec string leak out. Eval and exec are super, super dangerous. Do not use them unless you are really confident that you know what you're doing, or if you don't know enough to know that you shouldn't use them, right? Well, I've definitely encountered people like that. Oh, we use exec all the time. What could possibly go wrong? Oh, I don't know. Evaluating random code from your user input? What could possibly go wrong? Luckily, there are no bad people on the internet, so we don't need to worry. In any event, exec takes the string, it executes it, and it usually puts whatever values that were assigned into our global namespace. But there's another way to run exec. If we pass a dictionary as a second argument to exec, then the assignments will go into that dictionary rather than into our global namespace. That's pretty great. So if I say here, for example, s equals the same as before, and then I define an empty dictionary, and then I say exec s comma d, we see hello printed, we see goodbye printed, but now d of name is set to Reuven. We have assigned it into that dictionary. Now this might seem like very, oh, we got plenty of time. I'll tell even more bad jokes. Fantastic. Basically, when we assign into this dictionary, it might seem kind of strange, but there is a very clear reason why this exists. And that is because module objects contain dunder dict. Dunder dict is yet another one of these attributes that's set sort of magically on an object in Python. And in this case, dunder dict on the module reflects all of its attributes. So if there is a key value pair in dunder dict, we will see that key as an attribute on the module object and the value as, well, a value. So if dunder dict is a key A, the module has an attribute A. And whatever the value is for that A in the dict, that's going to be the value in the module as well. So here's what we can do. We can read the source code from the module, We can execute it with exec, and then we pass exec a second argument, the module's dunderdict. Now remember, before we read the source code and before we execute it in this way, the module object already exists. It's not that we have to create a new module object. It's already there, so it already has dunderdict. All we're doing with this exec is populating its namespace via dunderdict. I should add, by the way, that one way to do this would be just open up the module source code, just like read, read it as a binary, hand it off to exec, I guess it would be as text, right? And hand it off to exec, and then have that happen inside of the dictionary. Regardless of how we do it, after we've done that, all the global assignments in the module are now attributes. And this is something that people don't notice, that if I have X defined as a global variable in my module, let's call it my mod, then when I import my mod, I have my mod.x with that value. How does this transition happen between a global variable in my module and an attribute on my module object? And the answer is this when we use exec. But really, why should I be working hard? I don't want to work hard. I'm just going to use the loader's exec module method. That is to say, I go to the spec, the module spec object. I turn to the loader that was defined for this module, and I say, hey, loader, can you go and execute this module? Execute this module random. Meaning it's going to go to the spec source code, execute it into the random's dunderdict, and right after doing that, I random ran int 0 to 100, 31, and it works. This is what happens when you import a module every single time. Phew. Now I should add, all of this is customizable. If you want to find your modules in a new way, you can write a custom finder, and you can put that on sys.metapath. You want to find things in the file system in a special way, there are custom path finders. You want to load data in a special way, there are custom loaders. I was just speaking to someone earlier today who said that they were using this sort of mechanism at their job to do encrypting and decrypting of things, to make sure that things actually had the right, that they weren't spilling out and being shared with the wrong people. So you can do all sorts of wild, crazy things, hijacking the import system at various points, and then inserting your own code into it. So let's summarize things a little bit. What happens when you import? A lot. Okay, let's summarize things a little less. So first of all, Python checks to see if the module has been cached in sys.modules. If so, then it just returns the module and assigns the variable, we're done. If not though, then it goes through each of the finders in sys.metapath. If none of them finds the module, then you get an exception. But if they did find it, then you get the module spec. And based on that module spec object, Python creates a new empty module object. And then it uses the loader that's named on the spec, to exec the source code into the module's dict, making the globals from that file into attributes. That's not too bad, right? Oh wait, we didn't talk about packages. Next year. Because basically, packages are where things get really icky. What is a package? A package is a directory containing module files. And nowadays, we have namespace packages, and we have traditional packages with dunder_init.py, which is then executed. Do you execute it? Do you not? How does the namespace work? What is loaded? What happens when you then do relative imports? What's with the dots? Oh my God, it just gets really, really messy. And a lot of the modern hairiness of the import system is to deal with packages. Now, packages are important, don't get me wrong, right? Because if I've got a large project, it's probably not a good idea to put everything in the same big file. I want to break it up, both for my sanity and so that I can collaborate with other people. But packages do get kind of messy then, and so we're going to leave that for now. However, the mechanism is basically the same mechanism, just sort of cranked up a bit. That suddenly Python is told, don't just look here, also look there, here are the levels you're at. But the same basic idea, finders, loaders, importers, exec, all of that is still there. Anyway, I hope that this was helpful and enlightening to understand that what looks like a really, really simple system can actually be really hairy and complex under the hood, that Python has done an amazing job of sort of covering up the complexity of the importing system. I hope it was fun and interesting. I would be happy to speak with any of you. You can take some questions now. And I also have a booth outside, and I'm happy to come talk to you there as well. Anyway, thanks very much.